Hello everyone, welcome to my channel. In this video, we are going to learn how to perform facial recognition with high accuracy using the Python facial recognition library and Opencv Python. We are going to start step by step, and at the end of this video, you are going to have a face recognition project with high accuracy as your own, which you can showcase. So stay tuned till the end of this video. Now let's get started. I have created a file named main.py, and inside our main directory I have this folder with these images: Bill Gates, Elon Musk, Jeff Bezos. So these are the images we'll be going to use in this project. So we'll use them to be able to recognize whether this is Jeff Bezos or Elon Musk. So let's go ahead and get started. To start, we will need to install some libraries. So we need NumPy. So let me go to my terminal. So we can install pip install NumPy library. So I've already installed, that's why I signed it. And we need to install CMake, the same thing, CMake. I've already installed it, as you can see. And we need to install dlib. It's already installed too as well. Dlib, when you have a problem, you can use this command to get it installed: conda install dlib. Then let's go ahead and install our face recognition. Face recognition. Face recognition. Face recognition. Let's install this. It is already there. Now let's install Opencv. Opencv Python. It's already satisfied. Once we finish installing this, now let's import them to our project. Import NumPy as np. Now import face recognition, import cv2. Now once we are done importing all our libraries, now let's now load the image that we'll be using. We now say img is equals to, we are going to use the face recognition library to load the image. So let's go ahead and do that. Face recognition dot load image file. Now let's pass in the file directory. So it is in images. I'm going to load in Bill Gates. So now I've finished loading this one. Let's go ahead and convert the image to RGB, because the image we are getting, the library use BGR, so we need to convert it to RGB, which will be used by Opencv. So let's go ahead and do that. img is equals to cv2 dot cv color, and now let's pass in our image img, and now let's convert it to RGB to BGR, because Opencv use BGR. So now cv2 dot color to RGB to BGR. So once we are done converting it to RGB, let's go ahead and do the same to our test images, the image we'll be using for our test. So let's copy this one, paste it. Now this is going to be the one we are going to test against. See, test mg test. So let's copy, let's replace this one here. So we have been able to load our images. So what we can do is we can show the image to see whether it is loaded or not. So to do that, what we are going to do is cv2 dot im show. Now let's pass in the name of the window, which is going to be my, let's say, Bill Gates. Now let's pass in the image now, img. Let's do the same for the test. So is the test, that is for the window, and now let's pass in this image. To do that, before we can show the image, let's do cv2 for the delay, cv2 dot wait key, then let's pass in 0. So it's going to wait infinity till we press the 0 key to stop it from running. So let's right click on our project and run, and let's see what we get. As you can see, this is test, and this is the image. So let me end it by pressing 0. Now let's change this image to 3. Now let's save it and run it again. As you can see, there are 2 different images. So we are going to make our program to identify whether this is Bill Gates or not. So let's go ahead and do that. So now, once we are done loading the image, let's now convert, let's now find the face location in the image and now see what we can get from the face location. To do that, let's go here. I'll give a space here. It's a face location. Face location is equals to face recognition dot face locations. Then what we are going to do is to pass in our img image, which is going to give us an array. So we want the first one. So what we can do is we can do the same for the test image as well. Let's copy the same and paste down here, and let's change it face lock test. This is a test. So we can now print to get our face location to see whether we are getting the face's location. So let's print and see. Now let's change this one to test radar. So now let's print and see we are getting the image locations. Print face log first one, face log test. Let's go ahead and run our code. You can just click this button to run. Now let's see whether, as you can see, we are getting our image locations, which is giving us a tuple of the coordinate, the y, x, x1, x2, y1, y2 coordinates. So let's go ahead and close it. Now, to be able to compare these images, let's try to draw a rectangle on the images we found, so that we'll be able to get the face location to see whether we are getting the right face location or not. So to do that, we are going to use cv2 dot rectangle to get the face. So we are going to pass in the image, and secondly we want to pass in the face location coordinates, which is actually the tuple we are getting. So to do that, we say face log, then we take in the third index, the fourth index, then we take in the first log, also take in the 0 index, So let's actually put this one in a tuple like this, like this. Now let's get face look. It's going to be the first and the first in the large, which is face look, that we get in the 0 index, the first index. So now the next parameter we are going to use is the color to draw the box on rectangle on the face. So let's go ahead and do that, which is also going to be a tuple that will give us the RGB color. So we are going to declare 255 0 255, and the thickness is going to be 2. For that, let's copy this one and do for the test to be able to get the face, draw the box on the text image too. So now let's change this one to test like this, like this, like this, like this. So now let's go ahead and run our code and see what we are getting. As you can see, we are getting it wrong here. So I think something is wrong. So let's go ahead and do the correction here. It is not actually this image, so we need to pass in the test image. So let's save and run our code again. As you can see, this is what we are getting. We are able to get the face location, but I think something is wrong here. Our rectangle is too long, so let's do the correction. Let's do the correction here. I've seen the problem. So here is going to be like this. It is actually separate. Let's go ahead and do our correction, and let's do it like this, and separate them like this, going to be like this. So once the correction is done, let's save it and run our code again. Still, as you can see what we are getting, there's definitely something wrong here. So let's go ahead and see what we can do here. The problem is actually here. This is 2. This is 2. Now let's run our code and see what we are getting. Let's stop it and run it again. As you can see, we are drawing this pink line on the face. As you can see, this one too, we have these two images here. So now let's close them and now find the encodings of the image that we'll be using to compare whether it matches or not. So let's go ahead and do that. Now to find the encodings of the image, let's see what we can do now. Now let's find the encodings of this image. Since we are able to do that, we are now going to find the encodings of the image. Now encode img is equals to face recognition dot. Now we are going to find the encodings of the face encodings, and now we pass in our img, then we get the first index. Let's do the same for the test image as well. Now this is going to be img test, and this is going to be encoding image test. So once the encoding is done, let's go ahead and now try to compare these images. Let's go ahead and compare these images. Now what we are going to do is we are going to compare the images and see whether it matches or not. After that, we are going to put text on the images to get printed out and see the results. So let's go ahead and do that. So we are going to say results, or let's say match is equals to face recognition dot compare face recognition dot compare faces, and this is going to take a list of images. So we are going to put in the encodings and the test to see whether it matches or not. When it matches, it's going to give us true. When if it doesn't match, it's going to give us false. So let's go ahead and do that. So we are going to put in the encode img, then compare it to encode img test. So let's go ahead and print this and see what we get. Print match rather. Let's save our code and let's run and see what we get. If it matches, we are going to get through. Let's put them aside here and see what we get. As you can see, it said these two images match. That is why we are getting the true here. So let's go ahead and change an image and see what we are going to get here. Let's change our test image to something like Jeff Bezos and see whether it matches or not. Let's save and run again. Let's stop our code from running and let's run again and see what happens. Now this is Bezos. It is able to pick the face, and this is Bill Gates. It sells false. So to be able to get much accuracy from this, we are going to get the distance between the faces. So let's say you have a list of images and you want to find the right match. So what you can do is to get the distance. The lower the distance, the best the match. So let's go ahead and find the distance. So let's stop our code from executing. Now let's go ahead and do that. Let's find the match, the distance between our faces. So what we can do is we say face this is equals to face recognition dot face distance. Let's use this function. Then we are going to pass in the same parameters to see whether it matches or not. So we say encode img to this, to encode img test. So now let's print that one as well and see what we are getting. Face this. So let's print again and see what we are getting here. So let me push them aside so that we can see it says fault, and the distance is what, 0.73. So let's change the image. Let's stop our code and let's go back and change it to Bill Gates test and see. Bill 3, Bill 3, and let's save our code. Let's stop it. Let's run it again and see what we are getting. So let's put them aside here. As you can see, true, and the distance is 0.46. So this thing really matches. That is why the distance is much lower than the first. So let's stop our code. Let's now try to print the code on the text on the match on the result on the image by using CV2. For that, I have the code here. I'll just copy from my other machine and just paste it there so you can go through and see how it works. So let me do it here. We are going to do it on the test image. So let's change this thing to match. So what we do is CV2, then we put the text on the image to get it working. So let's go ahead and save and run again and see what we are getting. Now it says it matches. This is the test image. It said it match and it is 4.3. We've rounded it. I've just rounded it here. So let me stop it here. As you can see, what we do is take the face distance and get the first index and round it to two decimal places. Then now this is the position where I'm putting the text on the image. Then now the font, this is the font, and this is the color, and now this is the thickness of the text. So that is all for this video. Next video I'll be doing attendance system using my SQL database to be able to do attendance. You can load a lot of images to find out more. So stay tuned and subscribe to this channel so that next time I drop a video like this, you will be able to get it. Thank you. Bye.